This mini lecture in Ada is going to cover strings and input and output in Ada. Now, in the last lecture we saw how you can declare variables of different types, say integer, float, so on and so forth. The string type in Ada requires that we specify that as a string, but it also includes how big it is. Because in Ada, strings are arrays of characters. They're fixed size. Later in the class, we'll look at dynamic sized arrays, but by default, Ada focuses on fixed size variables. And this is very good in terms of memory management and performance, but it's bad in terms of flexibility. Because if I go through and just say, well, y equals hello, and we try to compile this, and then we run it, we get an error, because hello is not 10 characters long. It's 5. So if we look at our index, which then starts at 1, and we have 1, 2, 3, 4, and 5. And let's rerun this, and now it works. And I can do a put underscore line, have a y, and then this will allow us to output the variable. Now we do have to be careful because sometimes this variable may not actually be blanked out. See if I can get a case. So here, although I haven't stored any information in y, it holds the number 2. So just because we declare a variable doesn't mean that it is necessarily going to hold empty string values. Now, another way to access and to use strings is with input. So far all we have seen is how to hardcode values into this. And there are get and get underscore line, or sorry, put and put underscore line for output, and for input, as I just mentioned, there is get and get underscore line. So if we want to have the user type something in, I could say get y. And the reason why it's waiting is for me to type in 10 characters. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And it can continually ask for information to read until it gets 10 characters. And the reason why it's doing this is because we have specified that there are 10 characters in this particular string. Ada knows this at runtime. And whenever I'm getting this information, it's going to get 10 characters. Even if there are only 5 out there, it's going to keep waiting until it gets all 10 and then it'll return. So another method, if we don't want to keep getting information, is the get line method. Now the get line is going to read the specific information on the line. Well, it helps if you recompile. So if you don't recompile, you have the old information. So now we can see that it read in hello, and then we have extraneous characters at the end of our array. And that's what this x value is, because if we output x's value, and make sure we set the width to be 1, that way we don't get the annoying output, Now we can see, we know we have 5 particular characters. So if we want to specify this, we would go 1.5. And this is what we call an array slice. It's a portion of the array from characters 1 to 5. Now, obviously this was fixed for the hello example. If I change this to be x, now it will only output exactly what I want. So this is an example of strings and how to get input and output, obviously, for them. And the get is used, or can be used, for integers, doubles, and other variable types. The get underscore line obviously expects strings. And we have flexibility with the get line because it will tell us just how many characters it read on that particular line. Now, we can also run into situations where the get line will have only read part of a line, even though you say get the entire line, but it will only read up to the number of characters that the string can possibly hold. It won't go past the number. So even though you may have the get line, it may not get in an entire line of text. So be careful with how you're using input and output in Ada, and make sure you only output characters that you have actually input. Otherwise, you might get extraneous characters in your output. The next section will be dealing with conditionals and looping.